Okay, Harry has asked me to go over this question. This is my third attempt because it is important to take your time. So I'm going to pay attention to my own advice. Focus on this example. Park the assignment question. So let's just focus here. The steps to doing a normal distribution question is draw a curve, mark your mean and the standard deviation in intervals, and then line up your questions. Okay? So I'm going to just recite the question that we were given. I'm going to show it's from this book. I didn't note the page, but I can remember the question. So the question was, there's a milkman or woman, and they have a high street that they deliver milk on. The average times that it takes them is 12 minutes. Just make sure I'm not mixing up two questions. The average time it takes, sorry guys, is 12 minutes. The standard deviation is 2 minutes. Now, the different questions you're asked is find out how many days of the year does this individual take more than 17 minutes? How often or what percentage of days do they take less than 10 minutes? This is very like our speeding question, okay? And then between 9 and 13 minutes. Okay, that comes in the second part. Now, if I go back here to what I'm suggesting we do, you draw a curve, you mark your mean and the standard deviation intervals, and then you line up your questions. So there's 3 questions, so I'm going to actually do 3 curves. Okay. So I'm just going to do 3 little bell-shaped curves. Just so we've got some kind of visual here. Okay. Now, they're supposed to look the same, but I'm not an automaton. So the mean goes in the middle, so that's 12. So the first one, so if we were to do the intervals, we've got 14, 16, 18. Okay, so 1 standard deviation. I'm just going up in 2s because that's the standard deviations. So that's, I don't want to get it too messy, so that's 14 minutes, 16 minutes, 18 minutes. Then the other side, you've got 10, 8, 6. So I've just divided this up into the standard deviations. And unwittingly, I've done z-scores there, but anyway, so in other words, 1 standard deviation above, 2 standard deviations above, 3 standard deviations above, call that 0. 1 standard deviation below, 2 standard deviations below, 3 standard deviations below. So we know that 17 minutes is here. So that's 17 minutes. What's the next question? Less than 10 minutes. That's actually bang on here. So less than 10. So greater than 17, less than 10, and then between 9 and 13. So there's 1 standard deviation, there's 2 standard deviations, so 9, there's 1 standard deviation, and 13. So it's this bit in there. Okay, so there shouldn't be anything bothering you if you just slow down. You can pause it and just think it through, that a normal distributed set of data means that, so this represents 100% of the time. Okay, In between one standard deviation, you've got 67%, I think, or roughly. In between two standard deviations, it's 95%. In between three standard deviations, you've got 97%, I think. Google the exact percentages, because they always drift away from me. But in order to find these percentages, you've got to be able to extract them from this table. Okay, so let's just take a moment to look at this table. So we've got a diagram there that's showing similar to what I've just drawn, -3, -2, -1, 0, 1, 2, 3. That's reassuring. Okay. We're being told that 0 is 0.5. That makes sense because this is symmetrical, about the mean. 50% there, 50% there. Don't worry about all this gobbledygook up here. We're not concerned with that in this course. Okay. So the z-scores range from 50% to 100%, we're guessing. So if we go up to 3.09, you've got 99.9%. So you go from 50% to almost 100%. Okay? That curve actually never touches, even though it looks like it's touching. Theoretically, it never touches. So there's always a chance of being above or below. Now, let's take the first one. We need to read 17 minutes, but 17 minutes, you can clearly see, is 2.5 standard deviations above. But we need to be able to work with any situation. It mightn't be as obvious as that. So the way you convert these different questions into z-scores to read, a z-score is an expression. It's converting a score into how many standard deviations it is away from the mean. So it's either going to be below or above or below, and it'll be how many standard deviations. So it's very simple. You take the score, you subtract the mean, and you divide by the standard deviation. So we're taking 17, we subtract 12, and we divide by 2. Which gives me 2.5. And you can clearly see that's 2.5. So I go here, 2.5 is 99.38%. But the 99.38% gives you everything up to. So it's how many times they were less than 17 minutes. So you need to use this symmetrical 100% thing to subtract, and you get 0.62%. And if I calculate 0.62% of 365 days, that gives me how many days this milkman took more than 17 minutes. Okay, just quickly do that there. 365 multiplied by 0.0062. It's 2 days. I've rehearsed this beforehand. Okay, so we're on to our next one. Less than 10 minutes. So we know that 10 minutes is 1 standard deviation below. However, we're a bit stumped here because these are positive. It stops at 0. But because it's symmetrical, we can use this figure, 84.13%. So this side is 84.13%. Common sense. Okay? That is really, really, really common sense. It's the bigger of the two divisions. So this has to be 15.87%. So in this case, you just get 15.8. So 0.1587 multiplied by 365. Multiplication is commutative, and you get 58 days. Sorry, I'm looking at the paper, not the screen. Okay. So the trickier one, and you do have one of these, is to work out between 2 points. I'm going to stop there and take it up from that one. But just to recap, quick recap, is you just draw a curve, mark your mean and standard deviation intervals. I find that helpful. Line up your questions. So there I took the first one, I positioned the 17 minutes, and then I got a kind of rough idea of what was going on. Then you convert to a z-score. So that's the score minus the mean divided by the standard deviation. Okay. That gives you a number between -3 and +3, a decimal number usually, and then you just read from here. Okay. Now if I had 1.125, say, standard deviations, so 1.12, you might go halfway between those, but it isn't like that. So that would be the nearest. Maybe 1 point. There's different ways of reading these. Sorry, I'm looking at this instead of my screen. So to read this, if you had a less easy decimal, like 1.125, that's 1 1/8, you'd go 1.1 and then 2, probably round up to 3 and read this one. Okay? So there's a method of reading them. Sorry, went off on a tangent there. Focus on this example, park the assignment question. So you draw a curve for each, mark your mean and standard deviation intervals, line up your questions, convert to a z-score. Using the diagram, make sure what percentage you're looking for. So read the table. Use diagram. Better stop there, it'll be too long.